Today we're going to do the A4 notes, simplifying rational expressions. To get us started off, I did notice one thing that I want to change. If you could go to the second example A where it says multiplying and dividing rational expressions, if you could change this 4 to a 2, that will get us all set up and ready to go. All right. So this section, it starts us off with domain, which is a huge idea that we're going to deal with in pre-calculus and calculus. For now, we're just going to find the domain algebraically, and then in class I'll show you guys how to do it visually and all that great stuff. But the domain, that's going to be the set of possible numbers that make your algebraic expression defined or true. It's the x's that give you a y on your graph. To find it algebraically or just with an equation, some things that you can note. If you have a polynomial that doesn't have a fraction with a variable in it or any radicals, you can assume that its domain would be all real numbers. And if you remember, the symbol for all real numbers is that 2 lines with the R coming out of it. So every single number on the number line should yield an answer. For a radical, you can double check. If you want to try a radical, you can't take the square root of a negative number. For example, here's my calculator. If I try and take the square root of -9, it's going to tell me no real answer or error. So for radicals, the domain, if you want to find that, just set the inside greater than or equal to 0 and solve. So set inside greater than or equal to 0 and solve. Okay. The last one is a fraction, and if you remember from I think maybe 2 sections ago we were talking about properties of fractions. If you try to divide anything by 0, you're going to get error. That says divide by 0. There's a little bit of glare. You cannot divide by 0. So if you wanted to find a fraction or the domain restrictions of a fraction, what you can do is set the bottom equal to 0 and solve. So fraction, set bottom equal to 0 and solve. So these 3 examples right here is actually one of each. I'm going to come out real fast. The first one's just the polynomial, or actually binomial, x plus 5. There's no fractions, there's no radicals. If you were to graph it in your calculator, x plus 5 is a nice line that keeps going continuously. So its domain is going to be all real numbers. Part B, we have a radical. It's the square root of x plus 5. What you can do is, I don't know if that helps or not, is set the inside greater than or equal to 0 and solve. So here, your domain would be that x has to be greater than or equal to -5. If you wanted it to be written in notation, it would, since you are including -5, you'd have the bracket from -5 to infinity. Here, to find the domain restrictions for a fraction, it cannot equal 0, so I just set the bottom not equal to 0 and solve. So the only domain restriction is that x cannot equal -5. To write that notation, that means that you can go from any number all the way from -infinity to -5, not including it, and then on the other side of -5 to positive infinity. And then on the number line, it would look like this, with an open dot at -5. Colored in everywhere else. So that's a little bit on domain. It brings in the interval notation that we went over in the first section. Going back to what we did in A3, though, we are going to take our rational expressions and we are going to reduce them. A rational expression that just has 2 polynomials on the top, one on the top, one on the bottom, And it's kind of like if you were taking a fraction like 2/4 and you're reducing it down to 1/2. Here we're doing that exercise, but we're doing it with polynomials, which means that you need to be able to factor. Well, it's a good thing that we went over that last section. All right. So here, factoring this polynomial right here, the factors of -12 that add to get to 4 are going to be +6 and -2. On the bottom, you can factor a 3 out of both 3x and -6. So 3. If something is on the top and bottom of your quotient, you can cancel it out. So x minus 2's will cancel. And you can rewrite your simplified expression. X plus 6/3. Sometimes you might need to do a couple steps to factor it all the way. For example, on the top part of B, you can factor an x out, which leaves you with x² minus 4 on the inside. On the bottom here, let's see, you can factor x² plus x minus 2 into x plus 2, x minus 1. This binomial right here is the difference of two squares. If you remember, that is one of our properties that we learned about in the A3 notes. And that can factor into the sum and difference of the first and second term. So it's going to be x plus 2, x minus 2. Whoops, x minus 1. Again, if something is on the top and the bottom, you can cancel it out and rewrite your expression without those canceled terms. Whoops, I keep messing up that bottom. X minus 1. There you go. The next part that we're going to do is multiplying and dividing rational expressions. Here we go. What you need to know is that when you divide by a fraction, you can just multiply by the reciprocal, and it's good to factor, all right, just like we did before. To get us set up, though, let's see. Again, you can, instead of dividing by a fraction, it's good to go ahead and flip the second part of your fraction or part of this division problem and then multiply. So it could just become, let's see, 2 minus x over x² minus 4 times, and then just reciprocate the other part. So this is going to be x plus 2 over x² minus 5x minus 14. All right. Let's see. So let's go ahead and start factoring some things out. A little trick right here, you might notice that instead of having the x first, we have the constant term first and then a negative x. If that's ever the case, something that you can do, or a little trick, is to just factor out a -1. And then that would make the x positive and the 2 negative. There's that factored. Down here, x² minus 4, we just factored that up here. That's going to become x plus 2, x minus 2. X plus 2 we can't really factor much farther, but here the factors of 14 that add to get to -5, that's going to be x minus 7 and x plus 2. If you wanted to write a separate fraction, that would be perfectly fine as well. For spatial reasons, I'm just kind of writing it above and below the original problem. All right, so now it's time. If you see something, you can cancel it. If there's more than one thing, like on the bottom, like this x plus 2, there's 2 of them, and there's only one x plus 2 on the top, you can only cancel one of the quantities on the bottom. So here, this x plus 2 will cancel with this x plus 2. Or the other one. X minus 2 right here, and an x minus 2 right here. Leaving us with a negative 1 on top. And x plus 2. X minus 7 on the bottom. I'm fine if you leave it factored. Excellent. This one on the bottom, you're already doing multiplication, so you can go ahead and start canceling things. Let's see. One of these r's will cancel with one of these r's, but you'll still have an r on the bottom. This r squared minus 1, that's going to factor into r plus 1, r minus 1. The r minus 1 will cancel with this r minus 1, leaving you with r plus 1 over r. This last part we're adding and subtracting rational expressions, and I'm actually going to do this on a separate sheet just for spatial reasons. If you have nice small handwriting, you can probably do it right here, but I have a piece of lined paper that I'm going to do this on. When you add and subtract fractions, you need to get a common denominator, and here's what you do if you have denominators with x's in them. What you're going to do is get a least common denominator. And that's just going to take one factor that's included in each of the denominators that were given. And if it helps, I actually think it will always help, go ahead and factor everything out. So here the LCD, or the least common denominator, we're only going to have one of each factor. So that means that you're going to have an x plus 1, and an x minus 1. You don't need to list x minus 1 twice, all right? So what you're going to do is just take each term, and you're going to multiply it by the LCD, and that will make up your numerator. Your denominator is just going to be the least common denominator. Right? So here, the first part of our function, or our expression, I should say, 3x minus 1. I'm going to multiply that by the LCD. Here the x minus 1s will cancel. So this part of my numerator is just going to be 3x times x plus 1. I think it's almost easier to go ahead and distribute anything on this step. So this is going to become 3x squared plus 3x. Excellent. All right, the next term, carry the negative with it, so it's going to be negative 2 over x. I'm going to multiply that by the LCD. The x's cancel. So this part of your numerator, if you FOIL that out, that's going to become x squared minus 1, is going to be negative 2x squared plus 2. The last part, let's see, was x plus 3 over x plus 1, x minus 1. Multiply that by the LCD. Here, the whole denominator divides out with all of that part of the LCD, leaving you with x times x plus 3. And then distributed out would be x squared plus 3x. All you need to do then is just combine all of this part of your numerators, and then you're going to put it over your least common denominator. So let's see, 3x squared minus 2x squared plus 1. So 3 minus 2 plus 1 is 2x squared. 3x plus 3x is 6x. And then 2. And then you can put all of that over your least common denominator, which is x. X plus 1. X minus 1. For time's sake, I'm going to leave it like this. If you wanted to, you could try and maybe factor out a 2 from the top so that the top would be factored as well. Or if you wanted to leave this all